Okay, this video tutorial looks at the mathematical strand of real number, and more specifically we're going to focus on our understanding of decimals. Okay, sometimes you're going to be asked to write decimals in expanded form. And essentially what that means is that you have to have an understanding of what each different figure in the decimal actually means in relation to its place value. So as an example here we have a number 731.245. Now if we're going to write this in expanded form, the 7 actually represents 700. The 3 in the tens column actually represents 3 tens, or 30. And the 1 represents just 1 unit, so just a single number. Or a single digit, I should say. The decimal just comes down, and that's just simply a decimal point. Now the 2 is in the tenths column, so that actually represents 2 tenths. The 4 is in the hundredths column, so that actually represents 4 100ths. And the 5 is in the thousandths column, so that represents 5 thousandths. So if we're going to write this number in expanded form, it would be 700 plus 30 plus 1 plus 2 tenths plus 4 hundredths plus 5 thousandths. So here's some examples of writing decimals in expanded form. In our first example, it says write 0.45 in expanded form. Now, we have no whole numbers, so our first fraction is going to be the 4. Now, the 4 is in the tenths column, so this is actually 4 tenths. And we need to add the 5, which is in the hundredths column, so this becomes 5 hundredths. So 0.45 is actually 4 tenths plus 5 hundredths. In our second example, our first digit is the 6, that's in the tens column, so that actually represents 60, or 6 tens. Then we have our next digit, which is the units, so plus 3 units. Then we keep going down through and we keep adding what the actual place value represents. The 5 is 5 tens, the 6 is going to be 6 hundredths, and the 8 is going to be 8 thousandths. Now, sometimes you're going to be asked to write fractions in decimal form. Now, in order to write a fraction in decimal form, you need to know which place value column is represented by the denominator. Okay, as an example, if we have 9 tenths, that means we have 0 whole numbers and we have a 9 in our tenths column. So remember, the first column straight after the decimal is our tenths column. So this becomes 0.9, which is 9 tenths. 24 hundredths, again we have no whole numbers, and we have 24 in our hundredths. So the 4, or the last digit of our numerator, happens to be in our hundredths column. So it's 0.24. In our last example, we have 2 whole numbers, so 2 units. We don't have any tens, but we have 7 hundredths. I'll just write that again. 7 hundredths. And you can see that the 7 is actually in our hundredths column. So we're essentially looking at the denominator to work out which column our digit's going to be in, or the last digit of our numerator is going to be in. So sometimes you're going to be asked to determine if one decimal is greater than another. In order to do this, what you do is you compare the corresponding digits in each different place value column. And if they are the same, we then compare the next digit to the right. If they are different, then we go with the bigger number, or the bigger digit, to work out which is the bigger decimal. As an example, if we've got 0.364 and 0.3645, alright, the first thing we want to do is we want to look at the first digit in each of these decimal places. In this particular case, the first digit is both a 0. If it's the same, we move to the next digit on the right. In this particular case, we have a 3 and a 3. So it's the same. We then move along to the next digit. is a 6 and a 6. And we keep doing this until we get to different values. So if we move along to the next one, it's a 4, and we can see it's a 4. We move along to the next one. Now our first decimal number doesn't actually have another digit after it's 4. When it doesn't, we put in a 0. I think that's the wrong color that I've chosen. We put in a 0. And now, when we go to compare them, we've got a 0 and we've got a 5. Now we know a 5 is bigger than a 0, so therefore this number is the bigger decimal. So let's look at a few examples. We've got 3.562 and we've got 3.566. We start by comparing the first digit. Now here we've got a 3 and a 3. They are the same. We move to our next digit. We have a 5 and a 5. They are the same. We move to our next digit. We have a 6 and a 6. We move to our next digit. Here we have a 2 and a 6. Well, a 6 is bigger than a 2, so therefore this digit here is our bigger number. And if we were going to write this, we would say that 3.562 is in fact smaller than 3.566. Sometimes you're also going to be asked to write decimals in ascending order. And here's an example of how you do it. First thing we want to do is we want to find out what's the smallest number, because ascending is going from smallest to biggest. And we do that by comparing the digits in their place value columns. You can see that each of these numbers has a 2 at the start, so they've all got 2 units. After that, they start to change. You can see this has a 2 here, there's a 4 here, and there's a 0 here. Now 0 is the smallest number, so our first digit, or first decimal, sorry, would be 2.02. Then if we go back and we compare, we can say that a 2 here is actually smaller than a 4 here, so our next number must be 2.24, and our number after that must be the only remaining number, which is 2.44. Okay, so here are some practice questions I'd like you to have a go at that have covered everything we've done in this video. Please feel free to pause the video here, have a go at the questions. Once you think you've got them correct, continue the video and we'll go through the answers. Okay, so let's see how you went. First question says, what is 6/10 as a decimal? Well, in this fraction we have 0 units, or 0 whole numbers, but we actually have 6/10, and remember the first column is tenths, so our answer is 0.6. Our second question is, what is 2.45 in expanded form? Well, we're going to have 2 whole units plus 4/10, because 4 is our first digit after the decimal, and then we're going to have 5/100ths. In our third question, it says, what is greater, 3.4 or 3.404? If we write these out, we've got 3.4, 404. Compare the first digits, they're both 3s. Compare the second digits, they're both 4s. Now remember, if there aren't any digits afterwards, we put 0s. Compare the third digits, they're both 0s. But then it starts to get interesting when we compare the fourth digits, because that's a 0 and a 4. So therefore, this number is going to be greater. So 3.400 is in fact smaller than 3.404. And the last question says, write the following in ascending order. That's getting from smallest to biggest. We can see that each number starts with a 5. However, then we have a 4 here. The other two numbers both have 5s, so our first number must be 54.45. We can cancel that off now. Comparing the next two, we have both have a 5 and a 5, but then this one has a 4 and this one has a 5, so therefore this must be our next number, which is 55.45, and then our last number is the last one, which is 55.54.